Depending on the distribution of the intensity and relative uh, propagation time of waves and bandwidth of the transmitted signals. Okay, this is a change based depending on the distribution of the intensity and relative propagation time of the wave. It transmitted from the tower. This wave, it depends on the intensity. Intensity means the power ranges. Okay, the power ranges and relative times of the wave, power with the wave, and the bandwidth of the transmitted signal, the speed, the wave, and the power. Depending on this, then it can cause the resultant signals can be very widely in the amplitude. Okay, based on what? Based on the intensity powers, based on the time of the waves, signal waves, and the speed of the transmitted signals. Okay, and the factor influencing small scale fading. Fading, we already know this. Okay, fading is what? Fading is caused by interference between two or more versions of transmitted signals which arrive at a receiver at slightly different times. So these are the fading, and the factor influencing small scale fading are: number one, multi-path propagations that we already explained. A reflecting object and scattering in the channel create constantly changing environment that dissipates the signal energy in amplitude, phase, and time. This results in multiple versions of transmitted signals that arrive at the receiving antenna. This plays with respect to another in times of space. I hope that it's clear, this one. Reflecting object and scattering in the channel create constantly changing environment and dissipate the signal energy in amplitude. So reflecting object, scattering. Reflecting object means building, mountain, or any other things reflected the multipath, deflected the signals and created a multipath propagations. And also this scattering in the channel create constantly changes in the environment. So changing environments mean moving a device. Okay, moving device uh, dissipate the signal's energy in amplitude and phase time. Okay, in amplitude and phase times. This result in the multiple version of transmitted signals that arrive at the receiving end, displayed displaced with respect to another or to one another in time and space. Okay, in time and space. Number two, the random phase and amplitude of the different part component cause fluctuations in signal strength, causing small scale fading. Means random phase and amplitude. Random phase changes. If the object is moving, then it create the random phases and amplitude of different multipart component that causes fluctuation in the signal strength. So if we are moving too fast, if we are riding uh, uh, on a bike, or if I'm driving in a car, yeah. So if I'm moving too fast, then it create fluctuation in signal strength, posing as small scale fading. Number three, multipath propagation increase time required for the baseband propagation of a signal to reach the receiver, which causes signal smearing due to intersymbol interference. This will cause multipath propagations cause the time required for the baseband portion of a signal to reach to reach the receiver. Baseband and broadband is very much different. Baseband is a fully a digital band. Okay, fully digital band. If it is the broadband, then we can transmit different type of signals in a broadband. But in a baseband, uh, portion of signal to reach the receiver which cause signal spearings, okay, due to intersymbol interference. Okay, these are the point in this multi-path propagation. Factor influencing small-scale fading number B is the speed of mobile. The relative motion between the base station and the mobile result in a random frequency modulation due to a different Doppler shift of each of multipath component of each of multipath component. So here Doppler shift is positive of the mobile receiver in moving towards base stations, or is negative of mobile is moving away from the base stations. Let's see what is this in the graphical representation. Okay, Doppler shift in the mobile. Okay, we receive the signal from the tower, but the vehicle in the moving position. Okay, here the vehicle in the moving positions towards the tower or away from the tower. This will create the Doppler shift. Here, if we moving here and there, okay, here and there, moving the vehicles, then here that the circle is there, signal circle. Signal is based on the spectrum. Okay, from the radiated, it's radiated from the center. Signal radiations. Let me open another tab. Omnidirectional. Yes. Okay, using this omnidirectional antenna is radiated from the antenna. It's going like a ripple effect, or this it's sent out like a wave. Okay, in a wave. So these are the signal wave is radiated from the antenna. Here also is radiated from the antenna. If we are moving the vehicles, then it receive these radiated signals. Okay, so this is called the Doppler shift. Here the space is very less, and here space is very more. So this will cause towards the tower or maybe away from the tower. Okay, Doppler shift is possible if the mobile receiver is moving towards the base stations, and is negative if a mobile receiver is moving away from the base station. So a speed of mobile is very important in the small scale trading. Number C, surrounding of mobile. If object in a radio channel or in motion are in motion, they include varying Doppler shift or multi-part components. Already clear. If it is in the motions, then it's create the Doppler shift on a multi-part component. If the surrounding object moves, if the surrounding objects move at a greater rate than the mobile, then this effect dominate of small fading. Otherwise, motion of surrounding object can be ignored. This also one of the important surrounding of mobile. Surrounding of mobile. If the surrounding object move at a greater rate than the mobile, then its effect dominates the small scale fadings. Otherwise, motion of surrounding object can be ignored. Okay, these are the things in this factor influencing this small scale fading numbers. D is the transmission bandwidth of signals. If transmitted radio signal bandwidth is greater than bandwidth of the multipart channel, the received signal will be distorted by the received signal strength, will not fade much over the local area. So transmitted radio signals bandwidth. So the power strength and the speed is the bandwidth, the speed. Okay, the bandwidth means the capacity is not the speed, the capacity and the transmitted radio signals. Okay, and the capacity is greater than the bandwidth of the multipart, reflected part of the different object. Multipart channels, the received signals will be distorted. Okay, it will distorted. So let's say one example. From the tower is sent out the radio signals with a capacity signal bandwidth. These signals are reflected back and forth by the different type of objects, and it's come into a multi-part channel. So at the received signals, if it is greater than this, will be distorted by the received signal strength. Will not fade much over the local area network. Sorry, local area. Number two, If transmitted radio signal bandwidth is less than the bandwidth